All right, let's talk about trigonometry. Here's everything you need to know for the spiral review test. All right, first of all, what is trigonometry? Trigonometry is the study of triangles, but more specifically, trig is going to study the relationship between sides and angles of right triangles. All right, so how does it work? Well, angles and sides are connected. And what I mean by that is, if we have an angle, this angle is related to the length of the opposite side. The bigger the angle, as you can see over here, a larger angle creates a much longer opposite side. A smaller angle, and that opposite side gets smaller. Okay, so angles connect to the side opposite from them. This angle connects to this side opposite from it. All right, so keeping that in mind, and also understanding similarity, that all right triangles with the same reference angle are similar by angle. What I mean by that is, if we have two triangles that share this angle, they have one pair of angles in common, and then they also both have a right angle. And so angle similarity, we create two similar triangles. Okay, over here, same reference angle with a 90 degree and a 90 degree creates two similar triangles, our smaller version and our much larger version. Even over here, if we have a right angle and if the reference angle is congruent, then we have angle similarity. All right, if we have two triangles that are similar, then that brings us to this major conclusion, which is the sides are proportional. And so proportional, what that means is they grow proportionally. So if this, let's say, is 1, and let's say this is 2. Well, if these two triangles are similar, and let's say this is 2, we know that if this ratio is 1 to 2, right? The long side is twice as big as the short side, then the short side is 2, this long side has to be twice as big. And so we can use this similarity relationship, this proportionality, to find missing sides. All right, before we dive into the solving piece, we need to understand how to label a right triangle. So we always have to have a reference angle. Why is that important? Because if I point this way, am I pointing left or right? Well, from my point of view, I'm pointing to the right. From your point of view, I might be pointing to the left. And so it's important that we understand what our point of view is, and that's where the reference angle comes in. From the reference angle all the way across, that's our opposite side. Okay? The hypotenuse is always the one across from the right angle. Okay? It's the one that kind of goes diagonal. And then the adjacent means next to. The adjacent is always touching the reference angle and the right angle. Okay, and it doesn't matter how this triangle is oriented. It might be twisted, whatever. It still carries that same relationship. The opposite side is always across from my reference angle. Opposite side is across from my reference angle, no matter how the triangle is turned or twisted, all right? Okay, so once we know how to label the sides, now we can look at three relationships. Call them ratios. Ratio is just a fraction. It compares two things. So the most common ratio that you're probably familiar with is the slope ratio. And slope ratio compares rise over run. We're looking at three ratios. You can remember these by SO, CA, TOA. Okay? The SO stands for sine, is opposite over hypotenuse. CA, cosine, is adjacent over hypotenuse. And TOA means opposite over adjacent, stands for tangent. All right? So CA, TOA is an easy way to remember the definitions for these three relationships. All right, so here we go. This is probably why you tuned in here. Let's solve some problems using trig ratios. First thing we got to do is label. Remember, always from my reference angle all the way across, that's my opposite. Okay, this is my hypotenuse, and that means this side is the adjacent. Okay, so step one, label. Next, we got to pick a ratio. Well, to pick the ratio, I'm either using sine, cosine, or tangent. And that's where writing SO, on your paper can really help you out. All right, when we look at this problem, the only two that we have information about are the 16, and we want to know the x. And so I'm using my opposite and my adjacent. Opposite and adjacent leads me to tangent, okay? So label, pick a ratio. My ratio is tangent. Now I have to write an equation, and that equation looks something like this. Tangent of what reference angle? 44 degrees. And what is the tangent ratio? Tangent is opposite over adjacent. 16 over x. And here I am with my equation. Next, I use a calculator or a table, and I use my angle to find the ratio. All right? I took a snapshot of a table, what it might look like, and so I go on my table to 44 degrees. So I find 44 degrees, and I go over to the tangent ratio right here. All right, it goes sine, cosine, tangent. So 0.9657. So I replace tangent 44 with 0.9657. I put that over 1, because dividing by 1 never changes the value. And we have 16 over x. And from here, we cross multiply to solve. All right? I multiply 0.967 or 9657 times x, and I get 0.9657x equals 1 times 16, which is 16. And I divide both sides by 0.9657. And x equals, we might need the help of a calculator here. And so, if we go 16 it gives us 16.56. 57 if we round it. Voila. Okay, let's try again. Okay, so start off by labeling your sides. All right, from my reference angle, this is the opposite, this is the hypotenuse, and this is the adjacent. All right, so we look at the two players. Who is involved in this? Well, the 17 and the x, and so I've got my hypotenuse and my adjacent. That's h and a. H and a, oh, I'm using the cosine ratio. Okay, so I write my equation. Cosine of 54 degrees equals the adjacent over the hypotenuse, a over h, so x over 17. All right, next I use my angle to find the ratio. Remember, they're all similar, so if we know something about one triangle, we can use the proportions to solve. So I use my calculator here to find the cosine of 54. All right, to use your calculator, type in, for many calculators, you type in the angle first and then hit cosine. And it gives you our ratio of 0.5877. 0.5877. And put that over 1 equals x over 17. We cross multiply. 1 times x is x. And 0.5877 times 17. If you have it on your calculator, you just hit the times 17, and that gives us 9.99. We're going to round that up to 10. All right, so this is how we solve for a missing side. Let's take a look at how we solve for a missing angle. It's very similar. All right, notice the steps are the same. There's one slight difference. We've changed the order of this. We used to go angle to ratio, now we're going ratio to angle. But we start off by labeling. All right, from my reference angle, I label the opposite. This is my hypotenuse. This is the adjacent. And I look at the two players in the game. I know 19 and 16, so I'm using O and A. O and A leads us to tangent. So the tangent of some angle we don't know is 19 over 16. Okay? And right here, we use the ratio. Well, what ratio do we have? Well, the ratio is 19 over 16. On your calculator, type in 19 over 16, and that gives you 1.1875. So the tangent of some angle is the ratio 1.1875. Use this to find on your table, right? Where the tangent column, 1.18 is somewhere in between these. So if I'm using my table, all I know is it's between 49 and 50 degrees. So I can say my angle is between 49 degrees and 50 degrees, right? We don't know any more than that. That's as specific as we can be right now, and that's okay. All right, let me go through another example and I'll show you how you do it on the calculator. All right, we start off the same way, labeling our sides. This is the opposite, the hypotenuse, and this is the adjacent. We pick our ratio, and we pick our ratio by looking at the two values involved, 15 and 20. So we've got O and H. O and H leads us to sine. So I write my equation. Sine of some angle equals opposite over hypotenuse. Okay, and so I use this ratio, 15 over 20. Sine of some angle equals, and 15 over 20 is 0.75. Okay, and so on my calculator, if I'm doing this on my calculator, I do 15 over 20, gives me my decimal. I go to trig, and right here I hit the second button. And because I'm using the sine ratio, I use inverse sine. Inverse sine gives me my angle, which is 48.59 degrees. Okay, now I want to show you the notation on what happens between here and here. We would say our angle, in this case the question mark, is equal to sine, and we use this little -1. We call this inverse sine. Inverse sine of 0.75. All right, and what that means is we're just working backwards. It's a notation that says instead of using the angle to find the ratio, we're using the ratio to find the angle. All right, now that's everything you need to know for solving for a side or solving for an angle using trigonometry. Thanks for tuning in.